Isaac Newton. Sir Isaac Newton was an English polymath who played a significant role in the scientific revolution and the Enlightenment. His book, Philosophiae Naturalis Principia Mathematica, established classical mechanics and consolidated previous results. Newton also made significant contributions to optics and shared credit with German mathematician Gottfried Wilhelm Leibniz for formulating infinitesimal calculus. His Principia formulated the laws of motion and universal gravitation, which became the dominant scientific viewpoint until the theory of relativity. He used his mathematical description of gravity to derive Kepler's laws of planetary motion, account for tides, comet trajectories and equinoxes, and eradicated doubt about the solar system's heliocentricity. Newton built the first practical reflecting telescope and developed a sophisticated theory of color. His work on light was collected in his influential book Optics. He formulated the empirical law of cooling, made the first theoretical calculation of the speed of sound, and introduced the notion of a Newtonian fluid. He also contributed to the study of power series, generalized the binomial theorem, and classified most cubic plane curves. Newton was a Fellow of Trinity College and the second Lucasian Professor of Mathematics at the University of Cambridge. He was a devout but unorthodox Christian who privately rejected the doctrine of the Trinity. Early life. Isaac Newton was born on December 25, 1642, in Woolsthorpe Manor, Lincolnshire. He was educated at the King's School in Grantham, which taught Latin and ancient Greek, and likely imparted a significant foundation of mathematics. Newton was removed from school by his mother and returned to Woolsthorpe by Colsterworth by October 1659. He became the top-ranked student, distinguishing himself by building sundials and models of windmills. In June 1661, Newton was admitted to Trinity College at the University of Cambridge. He started as a subsizar and paid his way by performing valet duties until he was awarded a scholarship in 1664. At Cambridge, Newton read Aristotle's teachings and developed a mathematical theory that later became calculus. In April 1667, Newton returned to the University of Cambridge and was elected as a Fellow of Trinity. He was elected as a Fellow of Trinity in October 1669, and in 1669 Newton succeeded Isaac Barrow, who was anxious to develop his own religious and administrative potential. Newton's academic work impressed the Lucasian professor Isaac Barrow, who became master of Trinity College 2 years later. In 1672 and again in 1681, Newton published a revised, corrected, and amended edition of the Geographia Generalis, a geography textbook first published in 1650 by Bernhardus Varenius. The Geographia Generalis is viewed by some as the dividing line between ancient and modern traditions in the history of geography. Newton was elected a Fellow of the Royal Society (FRS) in 1672. Midlife. Newton's work on calculus, also known as flux ions or calculus, significantly advanced every branch of mathematics studied. His work, De Analysi per Equations Numero Terminorum Infinitas, was identified as an extraordinary genius and proficiency in these things. Newton later became involved in a dispute with Leibniz over priority in the development of calculus. Most modern historians believe that Newton and Leibniz developed calculus independently, although with very different mathematical notations. However, it is established that Newton came to develop calculus much earlier than Leibniz. Newton extensively used calculus in geometric form based on limiting values of the ratios of vanishingly small quantities. His Principia, which has been called a book dense with the theory and application of the infinitesimal calculus in modern times, is known for its use of methods involving one or more orders of the infinitesimally small. Newton was reluctant to publish his calculus due to fear of controversy and criticism. He was close to Swiss mathematician Nicolas Fatio de Duillier, who started writing a new version of Newton's Principia in 1691. The Royal Society accused Leibniz of plagiarism, and the dispute broke out in 1711 when the Royal Society proclaimed Newton as the true discoverer and labeled him a fraud. Newton is generally credited with the generalized binomial theorem, discovered Newton's identities, Newton's method, classified cubic plane curves, made substantial contributions to the theory of finite differences, and approximated partial sums of the harmonic series by logarithms. In 1666, Newton observed that the spectrum of colors exiting a prism is oblong, even when the light ray entering the prism is circular. This led him to conclude that color is a property intrinsic to light, a point that had been a matter of debate until then. From 1670 to 1672, Newton lectured on optics and investigated the refraction of light, demonstrating that the multicolored image produced by a prism could be recomposed into white light by a lens and a second prism. He also showed that colored light does not change its properties by separating out a colored beam and shining it on various objects, and that regardless of whether reflected, scattered, or transmitted, the light remains the same color. Newton concluded that the lens of any refracting telescope would suffer from the dispersion of light into colors, chromatic aberration. To prove this concept, he constructed a telescope using reflective mirrors instead of lenses as the objective. In 1704, Newton published Optics, which expounded his corpuscular theory of light, considering light to be made up of extremely subtle corpuscles and that ordinary matter was made of grosser corpuscles. He also constructed a primitive form of a frictional electrostatic generator using a glass globe. Subsequently, much has been amended, with Young and Fresnel discarded Newton's particle theory in favor of Huygens' wave theory to show that color is the visible manifestation of light's wavelength. Science also slowly came to realize the difference between perception of color and mathematizable optics. Newton's theory of gravitation began in 1665 and was rekindled in 1679 when he considered gravitation and its effect on planets' orbits. This led to a correspondence with Hooke, who opened a correspondence to elicit contributions from Newton to Royal Society transactions. Newton's interest in astronomical matters was further stimulated by the appearance of a comet in 1680 to 1681. After a brief exchange of letters, Newton worked out a proof that the elliptical form of planetary orbits would result from a centripetal force inversely proportional to the square of the radius vector. This resulted in the Principia, published in 1687, which stated the three universal laws of motion, which laid the foundation for classical mechanics. Newton also presented a calculus-like method of geometrical analysis using first and last ratios, gave the first analytical determination of the speed of sound in air, inferred the oblateness of Earth's spheroidal figure, accounted for the precession of the equinoxes due to the Moon's gravitational attraction on the Earth's oblateness, initiated the gravitational study of irregularities in the motion of the Moon, provided a theory for the determination of the orbits of comets, and more. Newton made clear his heliocentric view of the solar system, developing it in a somewhat modern way by recognizing the deviation of the Sun from the center of gravity of the solar system. He rejected criticisms for introducing occult agencies into science, but later rejected them in his second edition of the Principia, 1713. With the Principia, Newton became internationally recognized and acquired a circle of admirers, including Swiss-born mathematician Nicolas Fatio de Duillier. In 1710, he found 72 of the 78 species of cubic curves and categorized them into 4 types. Later life. Newton, a prominent British mathematician, was a member of the Parliament of England for Cambridge University in 1689 and 1701, and later became the Warden of the Royal Mint during King William III's reign. He took charge of England's Great Recoining and became the best-known master of the mint after Thomas Neale's death in 1699. Newton estimated that 20% of coins taken in during the Great Recoinage of 1696 were counterfeit, and he successfully prosecuted 28 coiners. In 1703, Newton was made president of the Royal Society and an associate of the French Académie des Sciences. He made an enemy of John Flamsteed by prematurely publishing Flamsteed's Historia Coelestis Britannica. In April 1705, Queen and knighted Newton, likely motivated by political considerations. Newton's work at the Mint was a continuation of his alchemical work. He was invested in the South Sea Company and lost £20,000 when it collapsed in around 1720. Newton died in his sleep in London on March 20, 1727, and his papers went to John Condit and Catherine Barton. A plaster death mask of Newton was molded shortly after his death, used by Flemish sculptor John Michael Risbrack in creating a sculpture of him. His hair was posthumously examined and found to contain mercury, possibly due to his alchemical pursuits. Newton, a renowned physicist and mathematician, was never married and was never subject to passion or commerce with women. His close friendship with Swiss mathematician Nicolas Fatio de Duillier ended abruptly in 1693, and he suffered a nervous breakdown, sending accusatory letters to his friends Samuel Pepys and John Locke. Newton was relatively modest about his achievements, writing in a letter to Robert Hooke in February 1676, "If I have seen further, it is by standing on the shoulders of giants." This statement, written during a time when Newton and Hooke were in dispute over optical discoveries, is believed to be an oblique attack on Hooke. However, the widely known proverb about standing on the shoulders of giants, published by George Herbert, suggests that a dwarf on a giant's shoulders sees farther than the two, placing Newton as the dwarf. In a later memoir, Newton wrote, "I do not know what I may appear to the world, but to myself I seem to have been only like a boy playing on the seashore, and diverting myself and now and then finding a smoother pebble or a prettier shell than ordinary, while the great ocean of truth lay all undiscovered before me." Theology. Isaac Newton, born into an Anglican family, held a Christian faith that was considered heretic by mainstream Christianity. He began recording his theological researches in notebooks, which have only been available for public examination since 1972. Over half of his writings concern theology and alchemy, and most has never been printed. Newton's writings demonstrate an extensive knowledge of early church writings and show that in the conflict between Athanasius and Arius, he took the side of Arius, who rejected the conventional view of the Trinity. He recognized Christ as a divine mediator between God and man, who was subordinate to the Father who created him. Newton warned against using the laws of motion and universal gravitation to view the universe as a mere machine, as he believed it could never be a circulating motion. He also studied the Bible and early church fathers, writing works on textual criticism and placing the crucifixion of Jesus Christ at April 3rd, AD 33. Newton believed in a rationally immanent world but rejected the hylozoism implicit in Leibniz and Baruch Spinoza. He believed in the ordered and dynamically informed universe could be understood by an active reason. His position was vigorously defended by his follower Samuel Clarke, and it was later discovered that Newton did indeed reject Trinitarianism. Newton and Robert Boyle's approach to the mechanical philosophy was promoted by rationalist pamphleteers as a viable alternative to pantheists and enthusiasts. The clarity and simplicity of science were seen as a way to combat the emotional and metaphysical superlatives of superstitious enthusiasm and the threat of atheism. Alchemy. Isaac Newton's papers contain an estimated 10 million words, with about 1 million dealing with alchemy. Alchemical texts combine artisanal knowledge with philosophical speculation, often hidden behind layers of wordplay, allegory, and imagery to protect craft secrets. Some of the content contained in Newton's papers could have been considered heretical by the Church. In 1888, Cambridge University catalogued Newton's papers, which were returned to the Earl of Portsmouth. In 1936, a descendant offered the papers for sale at Sotheby's, which was broken up and sold for about £9,000. John Maynard Keynes was one of 36 bidders who obtained part of the collection at auction. Keynes reassembled an estimated half of Newton's collection of papers on alchemy before donating his collection to Cambridge University in 1946. All of Newton's known writings on alchemy are currently being put online in a project by Indiana University called The Chemistry of Isaac Newton. Legacy. Isaac Newton, born in 1642, is considered the greatest genius and most fortunate person to have ever lived. He was also known for his mathematical principles, which led to the exploration of various phenomena such as planets, comet paths, tides, and rays of light. In 2005, a survey of both the public and members of Britain's Royal Society, formerly headed by Newton, found that Newton had made the greater overall contributions to the history of science. In 1999, an opinion poll of 100 leading physicists voted Einstein the greatest physicist ever, with Newton as the runner-up. New Scientist called Newton the supreme genius and most enigmatic character in the history of science. A parallel survey of rank-and-file physicists by the site PhysicsWeb gave Newton the top spot. Newton has been called the most influential figure in the history of Western science. Physicist Lev Landau ranked physicists on a logarithmic scale of productivity ranging from 0 to 5, with Newton being the highest ranking. The SI-derived unit of force is named the Newton in his honor. Woodthorpe Manor, his birthplace, is a Grade I listed building by Historic England. In 1816, a tooth believed to be belonging to Newton was sold for £730 in London, which would value approximately £25,000 in late 2001. The apple incident is a myth that inspired Sir Isaac Newton to formulate his theory of gravitation. Newton's niece, Catherine Barton, shared the story with Voltaire, who later wrote in his essay on epic poetry, 1727. Acquaintances of Newton, such as William Stukeley, confirm the incident, though not the apocryphal version that the apple actually hit Newton's head. Stukeley recorded a conversation with Newton in Kensington on April 15, 1726, where Newton thought that the power of gravity must extend much further than was usually thought. Newton was grappling with the idea that terrestrial gravity extends in an inverse square proportion to the moon in the late 1660s. It took him 2 decades to develop the full-fledged theory. He showed that if the force decreased as the inverse square of the distance, one could indeed calculate the moon's orbital period and get good agreement. He guessed the same force was responsible for other orbital motions and hence named it universal gravitation. Various trees are claimed to be the apple tree described by Newton, with some claiming it was purchased by the school, uprooted, and transported to the headmaster's garden. A descendant of the original tree can be seen growing outside the main gate of Trinity College, Cambridge, below the room Newton lived in when he studied there. Commemorations of Newton include his monument in Westminster Abbey, a statue of him at the Oxford University Museum of Natural History, a bronze statue of him in London, and a farmhouse at Woolsthorpe by Colsterworth, a Grade I listed building by Historic England. The Enlightenment. Enlightenment philosophers primarily used the works of Galileo, Boyle, and Newton as guides for applying nature and natural law to various physical and social fields. Newton's Principia, published in 1798, is considered a turning point in the scientific revolution and the beginning of the Enlightenment. This conception of the universe based on natural laws became a seed for Enlightenment ideology. Other philosophers like Locke, Voltaire, physiocrats, and Smith applied natural law concepts to political systems, economic systems, and sociology. Monboddo and Samuel Clarke initially resisted Newton's work, but eventually rationalized it to align with their religious views of nature. Works published during his lifetime: De Analysi per Equations Numero Terminorum Infinitas, 1669, published 1711, Of Nature's Obvious Laws and Processes in Vegetation, unpublished, 1671-75, De Motu Corporum in Gyrum, 1684, Philosophiae Naturalis Principia Mathematica, 1687, Caloric Scale, Calorum Descriptions and Signa, 1701, Optics, 1704, Reports as Master of the Mint, 1701-1725, Arithmetica Universalis, 1707, published posthumously, De Mundi Systemate, The System of the World, 1728, Optical Lectures, 1728, The Chronology of Ancient Kingdoms, amended, 1728, Observations on Daniel and the Apocalypse of St. John, 1733, Method of Flux Ions, 1671, published 1736, An Historical Account of 2 Notable Corruptions in Scripture, 1754. Thank you for watching and exploring the incredible life of Sir Isaac Newton with us. His impact on science and philosophy continues to shape our understanding of the universe. If you enjoyed this deep dive, please subscribe to Who is Who for more stories about iconic figures who changed the world, and turn on notifications to stay updated. Comment below if there's a historical figure you'd like us to cover next. Until then, keep questioning, keep discovering,